Okay, graphing inequalities is going to be very similar to graphing equations. The only thing we have to do is account for the fact that y is not going to be equal to mx plus b, but rather greater than, less than, greater than or equal to, or less than or equal to. So we have to find a way to denote on our graph if it is which of those four. Okay, so much like whenever we were doing simple linear, we had to draw on a number line, and we had to shade to show if something was going to be greater than or less than. We also had to say if it was an open circle or a closed circle, and that let us know if it was either less than or greater than, or less than or equal to, greater than or equal to. So similar to that, we're going to have different ways of showing on our line both what type of inequality we have and if it's going to be greater than or less than of its different type. So let's start by just looking at mx plus b. Just like it was with the equations, y equals mx plus b, m is going to be our slope, b is going to be our y-intercept. We're going to start with our y-intercept just like before. So in this case, my y-intercept is 4. So I'm going to go up 1, 2, 3, 4. I know my line has to cross the y-intercept here. Now I know that my slope is right here. -3 is the same as -3 over 1, so this gives me a vertical and a horizontal change. So I know that from here, my line is going to vertically go down 3 and horizontally go over 1. And I can keep this pattern going. 1, 2, 3, over 1, 1, 2, 3, over 1. Now comes the important part. I have to know if my line is going to be, in this case it's greater than, I have to denote if it's greater than or equal to, or just greater than. And as we talked about in class, we do this by either doing a solid or a dashed line. Because this is greater than or equal to, I'm going to have a solid line. So the solid line is kind of like having the filled in circle. We fill it in to show that anything on the line can be included. This is a solid line. All points on this line are parts of the solution. Now I see that it's y is greater than, so I'm going to shade everything above. Now, we don't always want to just shade by look. Sometimes we can deceive ourselves. So the best way to make sure you're correct is to choose a point to plug in. 0, 0 is the point I always use because it's nice and easy. In this case, 0, 0 is on the unshaded side. So if I've shaded correctly, that means when I plug in 0, 0 to this equation, I'm going to get an answer that does not make sense. So let's try it out. Okay, I'm going to erase this so that I have room to show it to you guys. So I'm going to plug a 0 in for y, and I'm going to plug a 0 in for x. Okay, -3 times 0 is 0. 0 plus 4 is 0. Is 0 greater than 4? Of course not. That doesn't work. That tells me that 0, 0 is a point that is not a solution, which means this side is the wrong side. Well, if this is the wrong side, this has to be the right side, which means I have shaded correctly. Any point that is on this side, any of these ordered pairs in here, should correctly solve this. If we wanted to make sure, we could pick a few points and plug them in and check. Okay, for the sake of time on this video, I'm not going to take the time to do that, but you are more than welcome to pause and practice with a few. Okay, moving on, let's try one more. I'm going to skip number 2, actually, and I'm going to move on down to number 3. So, just like before, we have mx plus b. I need to start with my y-intercept. So I'm going to come down 5. -5 is my y-intercept, so that's where I'm going to start. Now my slope, we've talked about this in class. If you just see -x, we know that's an understood -1x. Okay? 1 times x is x. -1 times x is -1x. Okay? -1, of course, over 1 would be our slope, so that we have a vertical and a horizontal change. So from here, I'll go down 1 over 1. I can't go any further, but my pattern does go in both directions. Remember, all we're looking for here really is the pattern. So if I'm going this way, I can also continue the pattern in the opposite direction. Okay. Now, to decide what type of line I have. This time, I have that y is greater than, and it cannot be equal to. Therefore, I don't want a solid line because I want it to be known that any point on this line is not actually a solution. This line is not inclusive to my answer. It's only going to be everything greater than this line. So I look, going up is greater than, going down is less than. Since my why is everything greater than? I shaded up. I don't want to just take that as the final answer, so I am going to choose a point. Again, I'm going to choose 0, 0. This time I see that this should work. So I'm going to plug in a 0 for y, greater than, I'm going to plug in a 0 for x. Well, negative 0 doesn't even, it's just 0. Okay, take away 5, and you get negative 5. Is 0 greater than negative 5? That, of course, is true, which means this point is a solution, which means this side of the inequality, or this side of the line, is where the solutions in fact lie.